So in this next video, we're going to focus on tangent. That last video focused on sine and cosine, and so if you haven't watched that video yet, you probably want to watch the sine and cosine video first. And so now we're going to focus on tangent. And so here, I filled in the column, or I started filling in the column for tangent. Apologies for how terrible my handwriting is with the mouse, but it goes from 0, and then at pi over 6, it's square root 3 over 3. At pi over 4, it's 1. At pi over 3, it's square root of 3. And then at pi over 2, it's undefined. And then those numbers repeat as we go around the unit circle using, like, this one is 1/2 over square root 3 over 2. This is square root 2 over 2 divided by square root 2 over 2 gives us 1. And then square root 3 over 2 over 1/2 gives us square root of 3. And so as we go around the unit circle, all of these numbers start repeating. Sometimes they're negative, sometimes they're positive. And then being careful, like sometimes our answer is 0 over 1, and sometimes our answer is 1 over 0. And so you just have to be careful with those values. So I'm going to take these numbers and I'm going to graph them on my tangent graph. And so this time, I'm going to change colors again. And so when I graph, I'm starting at 0, 0, and at pi over 6, my value is square root 3 over 3. So it's a little bit less than square root 2 over 2. And then at pi over 4, we're at 1. At pi over 3, we're at square root of 3. And then at pi over 2, we're undefined, which means, ooh, this is bad. We're an asymptote here, and so this is undefined at this location. And so we are not going to hit this graph. What we're doing is we're connecting all of these points, and we're going off to positive infinity. And then, when we keep going, we start at negative square root 3 over negative square root of 3, and then we go to negative 1, negative square root of 3 over 3, and then back to 0. And then these numbers start repeating. So this part will look exactly like this part over here. So square root 3 over 3, 1, square root of 3, and then we're back to our asymptote here at 3 square root of 2, or 3 pi over 2. And then we can connect these lovely values. And so as we approach on the left side, we're going to negative infinity. As we approach on the right side, we're going to positive infinity. And then we can keep going with this set here. And this graph here will look just like this graph over here. And there's another asymptote over here. So sorry, it's so messy. And so my graph is going up and going up and going up forever and ever and ever. And so the domain for this one is a little bit wonky. The range, we'll start with the range because that's a little easier. And so my range is going down forever and it's going up forever. And so this is going to be negative infinity to positive infinity. The domain is all real numbers except there's specific numbers that are left out. And so I'm going to say all real numbers except x cannot equal pi over 2, cannot equal pi over 2, but it can't equal anything plus pi units away from that. So plus pi n. And what n means here, so like we're taking x cannot equal pi over 2 plus all of the things that are 1 pi away, or 2 pi away for the next one, or 3 pi away for the next one, or 4 pi away for the next one, or 5 pi away for the next one. And so it's like at pi over 2, we're at negative pi over 2, we're at 3 pi over 2. The next one would be 5 pi over 2, and then 7 pi over 2, and then 9 pi over 2. Like we're going to keep adding a whole pi, or 180 degrees, away to the next one, and that's where the next asymptote is going to be. And so that's kind of how domain and range work on this, because there are x values that are left out that are undefined. And then here on this side, I have negative y values, and on this side I have positive y values, but those y values are the same, they're just opposite. And so that would make this an odd function. And so in our next video, we're going to start talking about transformations of sine and cosine. We won't do transformations of tangent, but you do need to be familiar with what tangent looks like. I hope that helps.